Hello everyone, welcome back to p33d. So now we're back to a one sample t-test. Remember, the main number that's going to change here is right there, the degrees of freedom, because we're going to have degrees of freedom on a t-test. Why? Because we're estimating the population standard deviation. What are we estimating it from? From the sample standard deviation. Why are we doing that? Because we don't have the population standard deviation. It's not given in the problem. So here we go. Many fitness centers and gyms, such as Gold's Gym and Planet Fitness, have introduced 24-hour access systems so members can work out anytime using their membership cards. How popular is this service? And how often do members take advantage of it during late night hours? Listed below is the number of members accessing the gym between midnight and 5 a.m. over a sample of 15 days at the Gold's Gym in Austin, Texas. Is it reasonable to conclude that the mean number of members using the gym during those hours is more than 50 per day? Use a 5% significance level. All right, so we want probability above. Case one-tailed right, and distribution is T, because we don't have population standard deviation, and then that forces us to T distribution, T functions, because it's a T distribution, null hypothesis, and the alternative, significantly more. Okay, so what's N? That's going to be a count of all these guys. Okay, so the mean for the population is 50, that's given in the problem. And as we know, that 50 carries over here to the sampling distribution, so might as well just do it right away. And then the sample mean is going to be the average of these numbers. And the sample standard deviation, the reason I'm doing this one first is because I need it for the other two. Standard deviation S of all these. And then that is going to simply be what we use for the population, since we don't have that. And then for our sampling distribution, there's mu, and then the standard error, which is this one here, is going to be equal to S divided by the square root of N. All right, so let's take a look at the picture. So there's our sample way out here. Here's the population. Here's the sampling distribution. As you can see, our sample is way out on the sampling distribution. So that looks encouraging as far as rejecting the null. So what are the degrees of freedom? That's going to be equal to n minus 1, because it's one sample t-test. Then the observed difference from mu is x bar minus mu. And then the t-score is going to be that observed difference divided by the expected variability. And the probability of getting that is t dot dist. Okay, and remember t's got the right and left version, so that's kind of cool. So dot rt x, and then there's our degrees of freedom. So basically a 1% chance that we'd observe that, but let's get the cutoff in there. So that was 5%. And as you can see, we're well within the rejection region. And what would this critical value be right here? So that's going to be t dot inverse dot, well, let's see if there's an RT version. Apparently not. T dot inverse. And the probability is going to be 1 minus this guy. And then our degrees of freedom. So 1.76, and that's exactly what that is. Okay, so the conclusion is we're going to reject the null. The reason is that probability of observing x bar is less than alpha. The interpretation of that is that our members use more on average than the population average. And so we're rejecting the null. If we're wrong, this would be a type 1. Sorry, type 1 error. If we're rejecting and the null is actually true. Okay, so now we get our new confidence interval. And we start with x bar. And we're going to, let's also bring down the original mean, which was the 50. All right, because we're rejecting, we expect this to be outside of the confidence interval of where we think the real mean is. All right, and so that's going to be equal to this guy minus the absolute critical value times standard error, and that's equal to this number plus the absolute critical value times the standard error. So we think that the real mean, population mean, is in this range, not the 50. And if you go back to the picture, right, that's for this sample, that its real population mean, right, is in that range there. We probably could draw little lines there around it, and you'd get that population for that guy. So it doesn't really belong to this population, which is why we rejected the null. Okay, and then you've got those questions about understanding relationships among variables, which you've seen previously, so I'll leave you to those. Sounds good. That's it for Prep 33.